Hello, good morning, and welcome to yet another class on the topic simple equation. Today's class is a continuation of our previous class on the subtopic change of subject of formulae. Previously, we have defined what we mean by change of subject of formula, and we have seen examples and have equally solved exercises for you on those particular examples. Today we are going to be talking more on the change of subject formulas, but a different kind of formula, not a simplified formula as was presented in the last class, but a more kind of a fractional and complex formula will be treated in today's class. But before that, let's look at some of the objectives of the topic as stated on the board. That at the end of this topic, each student should be able to change the subject of a given equation and solve problems involving change of subject of formula. Previously, we have defined a formula as an equation in which letters represent quantities. And we said formulae occur in several physical and daily activities, and there are situations that necessitate the rearrangement of equations, which results in changing the subject of such formulas. And in our previous class, we have solved some simple equations. In this class, we are going to continue with some more complex examples or equations as stated on the board. Example 3 says, given the equation 1 over u is equal to 1 divided by f minus 1 divided by v, and that we are to make v the subject of the formula. Making v the subject of the formula means that we should express v as a function of every other variable such as u and f. So with our knowledge on that, is going to be 1 over u being equal to 1 over f minus 1 over v. This is the question as given. What I'm going to do is I'm going to make 1 over u to stand alone, thereby moving 1 over v over 1 over f to the other side of the equation. Also, I may decide to move 1 over v from the right hand side to the left hand side, and I think that will be better. So I'm going to say subtract or add 1 over u to both sides of the equation. I'm adding simply because 1 over u has a negative sign. So this is going to be 1 over u plus 1 over v being equal to 1 over f minus 1 over v plus 1 over v, of which 1 over v plus 1 over v is 0, and this can be simplified to be 1 over u plus 1 over v being equal to 1 over f. I have succeeded in moving 1 over v to the left hand side of the equation. I'm equally going to move 1 over u to the other side of the equation. And how am I going to do that? I'll do that by subtracting 1 over u from both sides of the equation. That will give us 1 over u plus 1 over v minus 1 over u is equal to 1 over f minus 1 over u, of which minus 1 over u plus 1 over u will be equal to 0, leaving us with 1 over v on the left hand side, which is equal to 1 over f minus 1 over u. Now, I have succeeded in making 1 over v the subject of the formula, but the question said I should make v the subject of the formula and not the inverse of v. So what I'm going to do next is to try and simplify what I have on the right hand side. So I'm going to look for the LCM of 1 over u of f and u, and the LCM of f and u is fu. Fu divided by f is going to give you u, and u times 1 will be u minus, I'll do same to the second term on the right hand side. Fu divided by u is f, 1 times f will be f, so that our equation becomes 1 over v is equal to u minus f divided by fu. Now I want to make v the subject of the formula, and what I'm going to do is I'm going to cross multiply to clear both fractions, and this becomes v into bracket u minus f is equal to 1 times fu, and this becomes v into u minus f is equal to fu, knowing fully well that 1 multiplying anything is that thing. Simplifying further, making v the subject of the formula after clearing those fractions, I'm going to divide both sides by what we have in the bracket, which is u minus f. Why am I dividing by u minus f? Simply because I want to make v the subject of the formula. So this is going to be v into u minus f divided by u minus f is equal to fu divided by bracket u minus f, and this will cancel this, leaving us with v is equal to fu divided by u minus f. With this, we have made v the subject of the formula. The next example says we should make g the subject of the formula in the equation t is equal to 2 pi into the square root of h squared plus k squared divided by gh. So we are to make g the subject of the formula, meaning g should take the place of t. And how do we do that? We can't just pick g and substitute it with t on the left hand side, but we are going to use the mathematical processes in actualizing this. So first thing we are going to do is we have, let me write the equation. T is equal to 2 pi root h squared plus k squared divided by gh. So looking at this, you discover that 2 pi is being multiplied by what we have under the square root sign. So what I'm going to do is I'm going to separate these two terms, 2 pi and root hg, and the opposite of multiplication is division. Only that way can you separate both of them. In order for me to make g the subject of the formula, being that 2 pi is being multiplied by root h squared plus k squared over gh, I'm going to divide both sides by 2 pi because 2 pi is multiplying h squared plus k squared over gh under the square root sign. So this is going to give us, dividing both sides by 2 pi, we have t divided by 2 pi is equal to 2 pi root h squared plus k squared divided by gh, all divided by what? 2 pi. Of which 2 pi will divide 2 pi and it will be 1. So we are going to have t over 2 pi is equal to square root of h squared plus k squared divided by gh. Now you will discover that we are getting closer to g, and g is can be found at the denominator of the fraction under the square root sign. So what I'm going to do is to first and foremost undo the square root sign, okay, and the opposite of square root is square. So when I square both sides, you discover that this square root sign will be removed. So I'm going to square both sides, and this will give us t divided by 2 pi all squared is equal to square root of h squared plus k squared divided by gh all squared, because I said square both sides. So the square of a square root is that variable. So square will cancel square root, leaving us with bracket t divided by 2 pi squared is equal to h squared plus k squared divided by gh. I'm going to simplify further the left hand side, of which we say a square of either a constant or an algebra or an expression simply means that term multiplying itself twice. So this can be simplified to be t divided by 2 pi times t divided by 2 pi is equal to h squared plus k squared divided by gh. When you simplify this, you are going to have t times t is going to give us t squared divided by 2 pi times 2 pi, for which 2 times 2 is 4, and pi times pi is pi squared. So I'm going to have 4 pi squared being equal to h squared plus k squared divided by gh. Okay, I'm getting closer. Now, in order for me to clear both fractions, I'm going to cross multiply, meaning I'll use the numerator on the left hand side to multiply the denominator on the right hand side, and I'll do same with the numerator on the right hand side and the denominator on the left hand side, leaving us with t squared times gh is equal to 4 pi squared divided by h squared plus k squared. T squared times gh will give us ght squared. Now when you multiply two algebraic terms, you need to arrange them in alphabetical order. G comes before h and h comes before t, is equal to 4 pi squared times h squared. This is equal to 4 pi squared into h squared plus k squared. Now I now have my g on the left hand side being multiplied with h and t squared. So what I'm going to do is, since g appears just once, I'm going to divide both sides by ht squared, so that there we equally move to the other side of the equation, and dividing both sides by ht squared, we are going to have ght squared divided by ht squared is equal to 4 pi squared into bracket h squared plus k squared divided by ht squared, of which ht squared will cancel ht squared, leaving us with g is equal to 4 pi squared bracket h squared plus k squared all divided by ht squared. And I think this cannot be simplified further. So this is the expression for g. So when you're asked to make g the subject of the formula in questions like this is what you have to do. Okay, still on change of subject of formula, we are asked to make the letter that appears in bold type the subject of the equation. And in this equation, b is appearing in bold type, so we have to make b the subject of the formula. On the left hand side, we have x being equal to pi a b. Making b the subject of the formula, you agree with me that pi is being multiplied by a and b, but b is the needed variable. So since pi and a are not needed, we have to move them to the other side of the equation, and we cannot subtract pi and a from both sides. Why? Because pi and a were not added. So you always do the opposite of what has been done. Since pi and a is being multiplied by a, we are to divide both sides by pi a. So dividing both sides by pi a, you will have x divided by pi a is equal to pi ab divided by pi a. Pi a will cancel pi a, leaving us with b is equal to x divided by pi a as the subject of the formula. In this next example, we are to make x the subject of the formula, being in bold form. So just like what we did in the previous example, we are going to unwrap this expression under the square root sign and make x the subject of the formula. So the first thing to do is to carry out the opposite of the operation square root, and the opposite of square root is square. So I'm going to square both sides, and that will give me r squared is equal to root x squared plus y squared all squared, and this square will neutralize the square root, leaving us with r squared is equal to x squared plus y squared. Our focus is on x. What I'm going to do is to subtract y squared from both sides. And why do I subtract y squared? Because y squared has been added to this side, to the right hand side. So I will subtract y squared from both sides. Whatever operation you are carrying out, whatever you are doing to an equation, whatever you do to one side, you do to the other side. Otherwise, that equation will not be balanced. So I'm going to subtract y from both sides, leaving us with r squared minus y squared is equal to x squared. Successfully, I have been able to move y squared to the other side of the equation, and I can still rewrite this as x squared is equal to r squared minus y squared, since both sides of the equation are equal. What I will do next is to make x the subject of the formula. I'm asked to make x the subject of the formula and not x squared. So what you will do is to do the opposite of square to make x the subject of the formula. And how do we do that? We are going to find the square root of both sides. So square root of x squared will be equal to square root of r squared minus y squared. And just like I told you, square will neutralize square root, leaving us with x is equal to square root of r squared minus y squared. Now, this square cannot neutralize this square root, neither will this. This is because this is an expression and not a term. So this, you using the square root to cancel the square is not mathematical. Okay, so but what I have under the square root sign can be seen to be a difference of two squares, and with the knowledge of difference of two squares, we can still simplify this to be x is equal to square root of bracket r minus y into bracket r plus y. But in other cases, you can just stop at this point, and if you want to simplify further, then you can express it in this form. Both are still the same. Next is a simple sum of an AP, equation for sum of an AP, and we are asked to make A the subject of the formula. This equation can still be simplified or written as S is equal to n into bracket 2a plus bracket n minus 1 d all divided by 2. When you simplify it this way, it becomes clear to you on what next to do. And what I will do next is to try and get rid of the fraction. So I'll either say I will multiply both sides by 2, or as normally, as some people will say, or as some authors will say, you cross multiply, and this will leave us with, when you cross multiply, you're going to have 2s is equal to n into bracket 2a plus n minus 1d. For you know that when you multiply anything times 1, it gives you that term. Remember, our focus is on a to make a the subject of the formula. Therefore, I'll need to open this bracket, which means I will use my n to multiply every term in the bracket. So I'm going to open both the inner bracket and the outer bracket, and this will be 2s is equal to, let me first and foremost open that of the inner bracket, 2a plus, I'll use d to multiply every term in the bracket, d times n will give us dn minus d. Okay, that I have simplified. Now I can use n to multiply the whole bracket. This becomes 2s is equal to n times 2a will give me 2an plus n into bracket, let me put this in a bracket, n into bracket dn minus d, and I think I can still factorize out d. So this will be 2s is equal to 2an plus dn into bracket n minus 1. My aim is on a, so I'm going to subtract dn bracket n minus 1 from the right hand side to appear on the left hand side, because I want 2an to stand alone. That will give me 2s minus dn into bracket n minus 1 is equal to 2an plus dn into bracket n minus 1 minus dn into bracket n minus 1, of which positive this will subtract negative this, making it equal to 0, and this becomes 2s minus dn into n minus 1 is equal to 2an. Now my attention is on a, but I have it multiplying 2 and n, so I'm going to carry out the opposite operation of multiplication, and that will be division. But I can still rearrange this, take this to the left hand side, and move the other to the right hand side, leaving us with 2an is equal to 2s minus dn into bracket n minus 1. Next is to divide both sides by 2n. So this becomes 2an divided by 2n is equal to 2s minus dn into bracket n minus 1 divided by 2n. So this 2n will cancel 2 and n, leaving us with a is equal to 2s minus dn into bracket n minus 1 divided by 2n, and this is the subject of the equation. Next equation is one which I got from a WAEC pass question, and we are asked to make r the subject of the formula. So from this relationship we have t being equal to 3p divided by r plus s. So this is on the left hand side. On the right hand side is a two-term expression where we have this as the first term and s as the second term. So what I'm going to do is to first and foremost subtract x from both sides, leaving 3p over r. That is the term which has to do with r. Okay, thereafter I will now work on it. So subtracting s from both sides, we have t minus s is equal to 3p over r plus s minus x, of which plus x minus x will give us 0, and we'll have t minus s is equal to 3p over r. Our attention is on r. In order to make r the subject of the formula, I will cross multiply, or I will multiply both sides by r. So this is going to give me r into bracket t minus x is equal to 3p times 1, which is same as 3p. Next, I have made r to be at the numerator. What next to do is to divide both sides by the unwanted variable on the left, which is t minus s in brackets. So I'm going to divide both sides by t minus s. That will be r into bracket t minus s into bracket divide by t minus s is equal to 3p divided by t minus x, of which t minus x will divide t minus x once, and that will be r is equal to 3p divided by t minus x as r. equation. Next is for us to make r the subject of the formula, and in order for us to make r the subject of the formula, you discover that looking at the equation, it says h is equal to f squared over 2g into bracket r squared minus small r squared, and we are to make small letter r the subject of the formula. So in order for us to do that, we will first and foremost get rid of this term, and since it is being multiplied by what we have in the bracket, I'm going to divide both sides by this fraction, or I will multiply both sides by the inverse or the reciprocal of this fraction. That will be h times 2g divided by f squared is equal to f squared divided by 2g bracket capital R minus small r multiplying 2g over f squared. Now you can either multiply both sides by the reciprocal of f squared over 2g, or you say divide both sides by f squared over 2g. Both statements I have made are same thing, okay, and they are going to give you the same result. So whichever you are familiar with, you go ahead to do it, so long as it is within the mathematics principle. So 2g will cancel out 2g, and f squared will cancel out f squared, leaving us with h 2g over f squared is equal to capital R squared minus small r squared. Okay, so having done this, we are to make r squared, small r squared, or small r the subject of the formula. And what do we do to make it the subject of the formula? Since it is negative on this part, I'm going to move it to the left hand side by saying add r squared to both sides. So this becomes h 2g divided by f squared plus small r squared is equal to capital R squared minus small r squared plus small r squared, and minus r squared plus r squared is going to be 0 when you collect like terms. So leaving us with h 2hg over f squared plus r squared is equal to big R squared. Next is to move this term to the other side of the equation, since my attention is on R. So I'll subtract 2gh over f squared from both sides of the equation, and that will be 2gh over f squared plus r squared minus 2gh over f squared is equal to r squared minus 2gh over f squared. So plus 2gh over f squared minus 2gh over f squared will neutralize each other, giving us 0, leaving us with r squared being equal to capital R squared minus 2gh. Remember what I said? You arrange them in alphabetical order with the numbers written in front, divided by f squared. You can simplify this, or you leave it like this, and this is r squared is equal to big R squared minus 2gh over f squared. But our question is that we should make r the subject of the formula. So in order for us to make r the subject of the formula, from r squared we are going to find the square root of both sides. So if you find the square root of r squared, you also do same to the right hand side. This becomes r squared minus 2gh divided by f squared, of which square will cancel square root, leaving us with r is equal to square root of r squared minus 2gh divided by f squared as the subject of the formula. Next is also a while question, and we are asked to make r being in bold form the subject of the formula. Like we did in the previous example, we'll first of all get rid of pi h squared. And how do we do that? By dividing both sides by pi h squared. That will be v divided by pi h squared is equal to pi h squared multiplying r minus h divided by 3 divided by pi h squared, and pi h squared will get rid of pi h squared, leaving us with v divided by pi h squared is equal to r minus h over 3. Now we have two terms being on the right hand side. I'm going to move this term minus h over 3 to the left hand side of the equation, leaving r on the right hand side. So how do I do that? I'm going to add h over 3 to both sides of the equation, and this will be v divided by pi h squared plus h over 3 is equal to r. You can either leave it in this form or you simplify it. Okay, let's simplify it together. But I'm going to interchange the sides. So this is r is equal to v divided by pi h squared plus h divided by 3. Now this will be r is equal to, you will get the LCM of pi h squared and 3, of which the LCM of pi h squared and 3 is 3 pi h squared. Simply multiplying both denominators together and it will give you the LCM. If it is of letters, okay, if it is something you don't know the LCM, you can just multiply both the denominators and you get the LCM. So for us to get the new numerators, we are going to use the new denominator to divide each of the old denominators, multiplying it by the old numerators to get our new numerators, and that will be 3 pi squared divided by pi h squared will be 3 times v will give us 3v. So this is 3v plus, you do same here, 3 pi h squared divide by 3 will give us pi h squared, and pi h squared multiplied by h will give us pi h cubed. Okay, and our value of r is said to be equal to 3v plus pi h squared divided by 3 pi h squared as the subject of the formula. We are asked to make capital R the subject of the formula, and like what we have been doing, we are going to multiply, or we are going to undo the operation of square root, which is to square both sides. And when you square both sides, we are going to have I squared is equal to bracket square root of E divided by R squared plus W squared L squared all squared. So this square root will cancel this square and will leaving us with I squared is equal to E divided by R squared plus W squared L squared. We are to make R the subject of the formula. So what we'll do is to first and foremost clear the fraction of R squared plus W squared L squared, and that will be, how do we do that? We multiply both sides by this fraction, or we say you cross multiply, and that will be, if this is over 1, this will be I squared into bracket R squared plus W squared L squared is equal to E. Our attention is on R, so we are going to undo the operation of multiplication by dividing both sides by I squared, and that will be I squared into R squared plus W squared L squared divide by I squared is equal to E divided by I squared, and I squared will get rid of I squared, leaving us with R squared plus W squared L squared being equal to E over I squared. Our attention is still on R, so we are going to subtract W squared L squared from both sides of the equation, leaving us with R squared plus W squared L squared minus W squared L squared is equal to E divided by I squared minus W squared S L squared. So this minus this is 0 when you collect like terms, and leaving us with R squared is equal to E divided by I squared minus W squared L squared. Now we are almost done. In making R the subject of the formula, we will then find the square root of both sides. Finding the square root of both sides, you have square root of R squared is equal to square root of E divided by I squared minus W squared L squared. Let me put this over 1, and our square root will cancel this square, leaving us with R is equal to square root of E divided by R squared minus W squared L squared over 1. If you choose to, you can simplify the expression under the square root sign, and this is our equation of the formula expressing R as a function of E, I, W, and L. Alright, in this next example, we are asked to make Q the subject of the formula, and we'll still do same. First of all, undo the operation of square root and simplify further. So we are going to square both sides of the equation, leaving us with t squared is equal to bracket square root of PQ divided by r minus r squared q. Note that our attention is on r, so square is going to cancel square root, leaving us with t squared is equal to pq over r minus r squared q. Now we are to make q the subject of the formula, but we have q appearing in two terms. Okay, so what I'm going to do is to first of all factorize out q. So this is going to be t squared is equal to, before I factorize out q, I'm going to find the LCM of these two fractions. That will be, the LCM is r, and this is going to give me pq minus rq q. Okay, and I'm going to factorize out q being t squared is equal to q into bracket p minus r cubed all divided by r. Now I have been able to factorize out q. I'm going to make q the subject of the formula by multiplying both sides by the reciprocal of this, and that will be t squared times the reciprocal of p minus r cubed divided by r is r divided by p minus r cubed. This is equal to q times p minus r cubed divided by r times r divided by p minus r cubed. So you agree with me that this will cancel this when you simplify, leaving us with t squared r divided by p minus r cubed is equal to q. So this is the subject of the formula. Next question says we should make k the subject of the formula, of which on the right hand side we have two term expression. So I'll first and foremost move this to the left hand side of the equation by adding 5 mg to both sides of the equation, and this becomes t plus 5 mg is equal to n u squared divided by k minus 5 mg plus 5 mg. Whatever you do to the left hand side, you do to the right hand side. So when you simplify this, minus 5 mg plus 5 mg will give you 0, leaving us with t plus 5 mg is equal to n u squared over k. That's k squared. So I'm to make k the subject of the formula, but k is at the denominator. I'm going to bring it to the numerator by cross multiplying. So this is going to give us k into bracket t plus 5 mg is equal to n u squared. So therefore, in order for me to make k the subject of the formula, I'll divide both sides by bracket t plus 5 mg. Why? Because I want k to stand alone. So dividing both sides by bracket t plus 5 mg, we are going to have this divided by t plus 5 mg is equal to n u squared over t plus 5 mg. This will get rid of this, leaving our equation to be k is equal to n u squared divided by t plus 5 mg as our equation. And the last equation says we should make n the subject of the formula, of which n is appearing both at the denominator and at the numerator. So what are we going to do? I'm going to first and foremost simplify this expression by removing the brackets. And how do I do that? I'll do that by cross multiplying, or we'll say by multiplying both sides by bracket r plus n r. So this is going to give me I into brackets r plus n small r is equal to 1 times nr is nr. I'm going to open this bracket because my intention is to make n the subject of the formula. So I want to collect like terms, of which I have n in the right hand side and as well as at the left hand side. So I'm going to use this I to expand this bracket, leaving us with IR plus NR, sorry, this is small r by NRI is equal to NE. Next is to collect like terms. Collect all terms that have to do with R, N on one side. So I'm going to move this to the other side of the equation, leaving me with IR is equal to NE minus NRI. Next is to factorize out N, and this will be IR is equal to N into brackets E minus R I. I have singled out N. Next is to make N the subject of the formula by dividing both sides by bracket E minus Ri, and that will give us IR divided by E minus Ri is equal to N when you divide both sides. So therefore N is equal to IR divided by E minus Ri. So with this we have made N the subject of the formula. Thank you for being part of today's class. In our next class, we are going to be solving problems involving change of subject of formula. Kindly subscribe to this channel for more videos on change of subject of formulas and other topics on maths, physics, and further mathematics. Thank you very much, and God bless you.